So 9.4 is on using right triangle trig to solve for an angle. And so this will be really close to what we did in section 9.3, except for now we're solving for an angle instead of a side. So again, step one is identify the sides in relation to the acute angle. And that's the same thing that we did before, which is we're labeling. So we want to label our hypotenuse, our opposite, and our adjacent sides based off the angle that's either marked. I guess marked would be the best way to say that. The one that has the variable in the corner. Okay, and then we're going to choose the correct function. And again, our choices are the SOHCAHTOA. So remember again that sine, maybe we should write it like that. This is sine, this is cosine, and this is tangent. And it's going to be opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. We set up the equation like we normally would. And then the next thing that we're going to do is when we go to solve, the part that we're missing is the angle. And so we're going to be using an inverse in order to find our angle measure. And the way we do this is we push the second key and then whatever trig function that we're going to use. So we'll do second sine for sine -1, second cosine for cosine -1, and second tangent for tangent -1. So when you use a calculator, we just need to make sure that you're pushing the right buttons. So when we get go to example 1, it's the same idea. We look at our triangle and we label the pieces that we know. So as we look at it, we notice that this is the angle that's marked. So across from it is opposite. This is my right angle, so across from it is hypotenuse, which makes this side be our adjacent. And then just like we did in the last section, we look to see where we have value. So we have a number here and we have a number here, which is A and H. So we go to the top, A and H is cosine. So we're going to say cosine of angle B, because that's the one that we're looking for, is equal to adjacent over hypotenuse. So in order to find our angle, we do the inverse. So we're going to go B is equal to cosine -1 of 5 over 9. And then when we push it in our calculator, we are just going to go second cosine, and that's how we get the -1 up there. And then it is 5 divided by 9. Close our parentheses, and we get 56.3 if we round it to the tenths place, which it doesn't tell us in this one which place value, so we're just going to go with that, 56.3. If you're doing, just always read to see which place value it wants it to round to. Sometimes it will say round to the nearest angle, and sometimes it will have you go to the tenths place or hundredths place. So just make sure you read. When I do example 2, it's the same idea. We find the angle that's marked. So this is our angle that's marked with either a variable, question mark, the one that's unknown that we're looking for. Across from it is opposite. Here's our right angle. So across from it is hypotenuse. And this is our adjacent side. So again, we look to see where we have value. So we have value in opposite and hypotenuse because they have a number there. And so opposite and hypotenuse is sine. So we're going to go sine of angle B again is equal to opposite over hypotenuse. So to find our angle measure, we're going to find inverse sine of 11 over 12. And so again, we're just going to put that in our calculator. And so let me just move that. Oh, maybe not. Sorry. All right. So then we've got our small chart, and we're going to go second sine, and we're going to do 11 over 12. And so we get 66.4. And so that would be our angle measure. So the nice thing is it's a little, I mean, it's straightforward. We're just going to do almost what we did last time with just that added piece. We're going to do the inverse to find our angle measure. Just like last time as well, is when you have when you don't have a triangle, you're going to draw a triangle for these. So as I look at my first, for example 3, here's my triangle. And if I call this A and this B, this is always C, remember? And so angle A is the part that we're looking for. And it says given that side A is 9. So remember, the side is opposite of the big letter. So little a is going to be opposite of angle A. So this side is 9. And then B, being 16, is going to be opposite of big B. So that will be this side. And once I have that, then we can just say everything. I mean, we know that across from the angle is your opposite. Across from your right angle is your hypotenuse. And the other side is our adjacent. So when we look for what we're given, it's the same idea. We are given a value in adjacent, and we're given a value in opposite. And so opposite and adjacent is tangent. So we're going to go tangent of angle A is equal to opposite over adjacent. And so A is going to equal the inverse tangent of 9 over 16. So we're going to put that in our calculator. And we're going to go second tangent. And we do 9 over 16. And we get 29.4 if I'm rounding it to the 10th place. And it really is just that easy. We're just drawing our triangle that matches. And remember, you can draw your triangle however you want to. So if I decide to do it different, that's fine too. The main thing is the right angle is always your C. And then the other two, it doesn't matter. One's A, one's B. And you guys kind of get to choose that. So this wants you to find angle B. So this is the one that we don't know. Side B is 11. So across from big B is side B, which is 11. And opposite of big C is little c, which is 14. So when I go to figure out where I have, or if I go and mark my values, this is my opposite. This is my hypotenuse, which makes this be our adjacent. So when we look to see where we have value in opposite and hypotenuse, which is sine. So we're going to go sine of B is equal to 11 over 14. And so the way we find our answer is we're going to do the inverse. So inverse sine of 11 over 14. And again, we just put that in our calculator. And so we're going to go second sine 11 over 14. And we're going to get 51.8. Notice again, make sure you're rounding correctly. So you're looking at that second number, which is an 8, which bumps that 7 up to an 8. So be careful as you're rounding that you're doing that correctly. So I want to go over one more thing that you're going to see on your assignment today. And that's when you're asked to solve a triangle. And when you're asked to solve a triangle, that means you're finding all of the pieces that are not given. So you will be given some of the information, but you'll have to find the rest. And so on the back of your notes, if you can just flip it over, we're going to look at example 5. And so our example 5 is you have a triangle. And we're going to say this is C, A, and B. And we're going to be given that angle A is 32 degrees. We're going to be given that side B is 18. And we're going to be given, that's it. Okay. So what we need to do then is we need to find all of the missing pieces of that triangle. And so we have to look at it and figure out what we don't know. So we don't know angle B. We don't know side A, little a. And we don't know side C. So those are the things that we don't know. So notice we're given 3 of the 6 pieces. So there's 3 angles and there's 3 sides. And so we need to find the other 3 things. So we really are doing the same thing. We're just going to be doing multiple steps. So the easiest thing to find is the angle, because we know that all 3 angles of a triangle have to add up to be 180. And we know if angle C is 90, then the other 2 have to add up to be 90. So to find angle B, the easiest way to find that is just to go 90 minus 32. And when I go 90 minus 32, I get 58. And so that's going to be angle B. And that's pretty straightforward. We're just solving our triangle angles. All right. And so once we know that, that's great. I don't usually use it. I try to use the angle that's given. And so based off the angle that's given, we know that this is our opposite side, just like before. This is our hypotenuse side, which makes 18 be our adjacent side. And so as we go to solve, we want to solve for A. And so A is going to be using opposite and adjacent, which is tangent. So I'm going to go tangent of 32 is equal to opposite over adjacent. And now we're solving that equation like we've done in the past, which is how do I get rid of dividing by 18? I times by 18. This goes away, and we're left with A is equal to, and we just put it in our calculator. So we're going to go 18 times tangent of 32. And so that gives us 11.2, about. All right, so that means we're going to say our 11 is about 11, or our A side is about 11.2. So now if I want to solve for C, that's the other piece we don't know, then I want to use hypotenuse and I want to use adjacent, because I want to use what's given to me that I know is exact. 11.2 is not exact because it comes out as a decimal and we're rounding it. And so I like to use the exact values. So with adjacent and hypotenuse, that is going to be cosine. So we're going to go, I don't know if we can fit it there or not. We'll just do it underneath. So we're going to go cosine of 32 is equal to adjacent over hypotenuse. And again, we're going to solve that the way we normally would. So to undo dividing by C, we multiply by C. And so we're going to get C times cosine of 32 is equal to 18. And then we want to get C all alone, so we divide both sides by cosine of 32. And these go away. And then we're left with C is equal to whatever 18 divided by cosine of 32 is. So 18 divided by cosine 32. And so we get 21.2. And so that gives us our third missing piece. And so when it asks you to solve for solve a triangle, you're finding all of the missing pieces. All right, so sometimes it looks nice like that. And as we look at example 6, again, they don't have to give you a triangle. They could just give you the pieces that they might say something like this. Solve the triangle. Given, and we're going to just say given little a is equal to 10 and little b is equal to 8. Okay. And it will probably say something like solve the right triangle so that you know it's a right triangle, but you're going to draw your triangle. And then again, if it's a right triangle, we know this is C, and we're just going to call one side A, or one angle A and one angle B. And then it gives us the information. So it says little a is 10. So little a being 10 is across from big A. So this would be 10. And little b is 8. So across from angle B is 8. And so now when I look at that, I am looking for the missing pieces. So think about what I don't know. I don't know little c, so that's something that's I need to know. And I don't know angle A, and I don't know angle B. So those are the pieces that are missing. So notice again how I have 3 pieces, and I'm going to find the other 3. So when I look at this, the angle measure is not the easiest to find in this one. So the side might be the easiest, and you can either do a trig function, or you could, but if you do a trig function, you can't do that until after you find an angle measure. So if you have 2 sides of a right triangle, you know the third, because remember a squared plus b squared equals c squared in Pythagorean theorem. So we're going to say a is 10, so 10 squared plus 8 squared is equal to c squared. If I add these together, we get 164. And then remember, we want to take the square root. So we take the square root. 164 is not a perfect square, and so we want to break that down. So I think I'm going to wait for just a second here. So now we're going to divide that down. Let me add one more page. So we can slide it up. All right, so let's slide this up a little bit. So as we break this down, 64, let's just divide by 2. Well, we could divide, let's just do 2. So 2 is going to give us 82. 82 is going to be 2 and 41. And then 41 is prime. So we're looking for a pair. So we have a pair of 2's. And so our C value is going to be either 2 root 41, or if we want to, we could put that in our calculator and just go second square root of 164. That's going to be kind of dependent on what your assignment says to do. If it tells you to put it in simplified form, then it usually means keep it as a radical because that's simplified form. If it tells you to round to a place value, then you know you can just put it in your calculator. And we're going to say this is 12.8. All right. Now, when I go to find my angle measure, I definitely want to use the pieces that are given. The nice thing about when it's solving for an angle is you get to pick like which angle you want to solve for. You can either solve for A or B. It's not going to matter. You kind of get that option. And so if I was going to do, let's say angle A is the side I want to solve, or the angle that I want to solve for, then that makes this be my opposite. This is always hypotenuse. And it makes this be adjacent. And so if I want to use opposite and adjacent, then that's tangent. So I'm going to say tangent of angle A is going to equal opposite over adjacent. And so to find an angle measure, remember that's where we do the inverse. And then in our calculator, we're just going to plug that in. And we're going to go second tangent. And we're going to go 10 divided by 8. And so we get 51.3. And that gives us angle A. And then angle B is even easier. So to find angle B, all I have to do is go 90 minus 51.3 to find angle B. And the reason I know that is because I know that all 3 angles have to add up to be 180. If angle C is 90, then angle B has to be 90 minus whatever angle A is. And so if I go 90 minus 51.3, I'm going to get 38.7. And so this is solving this triangle, is finding all the missing pieces. All right, that's all for 9.4. Hopefully that's good for you.